Hey guys, what's up? It's DatAsianMathGuy. So in the last video we covered addition, which is over here by a plus symbol. So in this video we're going to be covering subtraction, which is a trickier concept to understand than addition. So let's start off with a simple problem. Let's say I have 64 minus 32. Subtract there. So same as addition, we start with the left or the rightmost row, sorry, and after we're done with, or sorry, column. Uh, so you start with the rightmost column, and after we're done with that column, move to the left, to the next column. So we have 4 minus 2, which is just 2, and we have 6 minus 3, which is just 3. There, so 64 minus 32 is just 32. Great. Let's do a harder problem. So let's go with a pretty tricky problem. As a comma. There. Yep, 5-digit subtraction problem. So we've got 42,000 down here. We've got 134. So start from here. 6 minus 4 is just 2. Move on to here. 4 minus 3 is just 1. 2 minus 4 is just 2. Comma here. 4 minus 2 is just 2, and 5 minus 4 is just 1. So 12,212. Pretty weird that I have only 1s and 2s in this answer, but anyways, let's move on. So, let's actually use this color. Okay. So, I want to introduce the concept, or a new concept, in subtraction. So, in the last video, I talked about the fact that we had to do a carry in addition. Now, in subtraction, it's not called carrying, it's called borrowing. So, let's show you guys. Okay, so we're still gonna have 64 over here, but we're gonna be having 35 over here. There. And I'm trying to do the subtraction. Same as always, we're trying to start from the rightmost column over here. 4 minus 5. Wait. 4 minus 5. What? 4 minus 5 basically means that we have 4 things and we're trying to give away 5 of them to, I don't know, your friend maybe. But that doesn't make any kind of sense, does it? Because if I have 4, for convenience, I'm just going to call them eggs. So if I have 4 eggs, I'm trying to give away 5 of them, so that's the first one. That's the second one. That's the third one, and that's the fourth one. How do I give away the 5th one when I don't even have a 5th egg? For now, that will remain as a mystery. However, this 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 exploration right here is going to uncover a whole new world of numbers called negative numbers. But that'll be a topic for a later video, because right now we simply don't have the time to be discussing negative numbers. But I will get there. So let's return back to this 4 minus 5. How do we do this subtraction? Well, basically what happens is we do this act of borrowing. So we cross out the 4 over here. We replace it with 4 plus 10, which is 14 over here. And we reach over to the tens column, cross out the 6, and replace it with the 5, which is basically just 6 minus 1. And these rules, or this set of rules right here at least, looks pretty arbitrary and pretty random. I mean, the first time I heard about this, I was like, What? What's the purpose of doing this? What's the purpose of adding 10 over here to this 4 over here, crossing out the 4, adding the 14 over here, crossing out the 6, subtracting 1 from the 6, and getting 5 and putting it on here? But for now, just bear with me, because there is an algebraic explanation that I will make a video about on the borrowing process of subtraction. So we have 14 over here minus 5, and that's just equal to 9. 9, and we have a 5 over here minus 3 equal to 2. Now another thing I want to mention about addition and subtraction is that they're inverses. So that means that, say for example, let's use this first example right here, 564 minus 32 equals 32, then 32 plus 32 is equal to 64. So if you write it out, so 64 is, or 64 minus 32 is equal to 32. And you guys might not know what I'm doing right here, but adding 32 on both sides. Actually, this notion of adding something to both sides, or basically doing the same thing to both sides, this won't come until later when we actually begin algebra and step out of arithmetic. So if you don't completely understand what is being done over here at the current moment, don't worry, because this is supposedly still supposed to, still supposed to be an arithmetic video, not really an algebra video. But anyways, there also is an explanation for why why addition and subtraction are inverses. But anyways, so we have 14 minus 5, 9, and 5 minus 3 is 2. So basically just know for now that addition and subtraction are inverses, that you can, that they essentially, quote unquote, cancel each other out. So I know this is getting a little bit rambly, but let's just try one more example problem and we'll call it a day. So let's go ahead and do something super monstrous. Let's do a 5-digit, or rather 5 column subtraction problem with borrowing involved. Actually, I just changed my mind. Let's do a 5-digit number subtract a 4-digit number with carrying involved. Okay, let's go. So we're gonna keep this original number right here, 54,346. Crazy number. So just as in addition, you basically line up the ones digit with the ones digit, tens digit with the tens digits, hundreds digit with the hundred digit, and so on. You get the idea. So say for example, if I had, let's see, if I had 5,457, it'd be like this: 5,457. So the reason I'm putting 5,457 here is because the units digit line up right here, 6 and 7. The tens digits line up 4 and 5 right here. The hundreds digits line up right here, 3 and 4. And the thousands digit line up over here, 4 and 5, sorry. And same rule still applies if any of these numbers, they don't have one of these digits, you can just add a 0. So here, the bottom number 5,457 doesn't have a 10,000s digit, so you can just add a 0 right here. So there you go, all the digits are lined up. So now let's try to do this subtraction. So we start here, 6 minus 7 perform a borrowing. So it's 16 right here, and we go ahead, subtract 1 from here. Coolio. Now we have 16 minus 7, which is just 9. So I'll write that down. 9. Okay. Now we have 3 minus 5. A little bit bothersome, considering that we have to do another borrowing on top of the borrowing that we already did. So what we do is turn 3 into 13, and go over here, pluck a 10 out of here. So it's left with 2. 13 minus 5 is just 8. Let me write this in the same color. 8. Okay. And now we do another double, or not double, sorry, borrow, which is a different color. So we're going to be replacing this with 12, and we're going to be taking a 3 from here. So 12 minus 4 is just 8 again. Oh, my 8 looks weird. Okay. Now we have to do another borrow, which is pretty crazy, but that's how we structure the problem. To give you guys some exposure to double borrowing, triple borrowing, quadruple borrowing. In fact, the borrowings can just keep on going. But anyway, so we have 3 over here, and place this with 13. Actually, so we're running out of space. So, and we take a 4 from here. And that concludes the borrowing that we just did over here. So 13 minus 5, which is another 8, coincidentally. 8. And we have 4 minus 0, which is just easy. 4. So we just went through this monstrous, we're not really that monstrous, but sort of monstrous, 5 column subtraction. So the original number was 54,346, can't really see, but minus 5,457 equals 48,889. So basically, the tricky part about subtraction is that is because of the borrowing, and in this case specifically, if the number of borrowings get to for example, if there are a lot of borrowings, a student might make a lot of mistakes. In fact, that actually happened when I was trying to record this video. I screwed up on the borrowing because there were so many borrowings. But anyways, just remember the rule of borrowing for now, and I promise that I will make a video dedicated entirely to why this procedure actually works. Why does subtraction work this way? And why does borrowing work? Why does adding 10 to this and then subtracting 1 from here actually work? So this basically is the end of this video. Basically remember to subscribe, comment, like, share, and in the next video we're probably going to be doing actually scratch that, we're definitely going to be doing multiplication, and we'll be looking at how multiplication is actually tied in to addition. And after that, we'll still be looking at division. And from there on out, we're basically done with arithmetic, and we're probably going to be starting to jump into the foundation of algebra. And so yeah, don't forget to subscribe, comment, like, share, whatever it is you guys do, and peace.